Good morning, friends. I'll read now SME PCC 2020-2018, Article 306, Mechanical Clamp Repair. The mechanical clamp consists of split fittings mechanically joined together to seal off or reinforce a component. Example of mechanical clamps are illustrated in Figure 306-1-1 and 306-1-2. Mechanical clamps can have variety of shapes, cylindrical, rectangular, with either flat or formed heads. Upon following the contour of the pipe or component being repaired, mechanical clamps can also be used to enclose components such as flanges, valves, fittings, branches, nozzles, or vents and drains. Mechanical clamps are often available with catalog items, or they can be custom made to two hub cells, a sealing gasket and bolts, or studs and knots. The annular space between the mechanical clamp and the repair component can be left either empty or filled in the lined with epoxy sealant, fiber, refractory material, or other compounds. A clamp can be non-structural, designed to contain leaks, or structural, designed to reinforce and hold together damaged component. The conditions that lead to crack formation and propagation have been eliminated so as the crack will not grow during the planned life of the repair. Witness for service assessment shows that the crack growth during the plant life is acceptable and the crack will not propagate across the clamp, or the crack circumferential and the clamp is structural clamp, where the clamp is designed for the case of full circumferential separation of the cracked component. A separate strong back assembly may be used to provide structural integrity, where the clamp only provides sleek seal. It is common for those two items to be independent through used in concert. Qualification, installation, and sealant injection where necessary shall be performed by personnel qualified under conditions representative of the field application. Safety personnel shall be aware of hazardous in installing clamps or degraded compounds and shall take necessary precaution to avoid unacceptable risk. The risk review shall be conducted before a clamp is installed. Personnel shall take any necessary precautions to avoid unacceptable risks. Square mechanical clamp over a drain branch. With sealant injection nozzle. Precautions: if the component is leaking or has the potential to leak during the installation, and if content are hazardous, additional precautions should be taken, and those precautions should be addressed during the pre-job hazard review meeting. Need for fresh air suit, etc. Materials: clamp materials shall be listed in the construction or post-construction code. Figures 306-1-1, 306-1-2, and be compatible with the fluid pressure and temperature with due consideration for the stagnant condition created by leak of fluid into the clamp. The mechanical clamp sealing element and its lubricant may prevent its use in high temperature service. Generally, the material of construction for the clamp should be similar to the clamped component. Clamp made of different materials shall be acceptable if they are compatible with the process and existing component. The clamp design and construction, including material selection, shall be done considering the deterioration made that led to need for the repair. The clamp shall be suitable for resisting the deterioration mode for the life of repair. The design life of the repair shall be based on the remaining strength of the repaired component, the corrosion resistance and mechanical properties of the clamp, its sealing element, and where used the sealant. Some sealant lose their sealing properties as hot line is cooled down or sealant can deteriorate over time. This shall be considered if leaving the clamp in place for a new heat-up cycle or beyond the manufacturer's designated time and temperature. Failure modes. External parts of repair components now enclosed by clamps, such flanges, bolts that could significantly degrade, crack, corrode if they contact with the leaking fluid. Because of the clamp can be at lower temperature than the component, condensate from leakage gases should be considered for its corrosive effect. The clamp can cause component to run at a different temperature, which can increase the corrosion rate or cause dew point corrosion. Process fluid contact of the insulating effect of the clamp may increase the temperature of the encapsulated bolting, causing it to yield. The development of operating and residual stresses due to constant differential expansion can cause the clamp to leak. Temperature and toughness. The clamp material shall satisfy the minimum temperature and, where applicable, minimum toughness requirements of the applicable construction code or post-construction code. Design conditions, mechanical clamps, sealing surface, and bolting shall be design conditions and anticipated transient loads imposed on the repaired pipe or component following the design requirements of the construction code and post-construction code qualification. In case where there is no applicable design requirements of the principles of the application construction code or post-construction code shall be followed. Components of the mechanical clamp that are fabricated by machining standard fittings, such as cutting out, opening in standard pipe caps to make end pieces, shall be qualified by analysis of testing as provided in applicable construction code or post-construction code and be reinforced if necessary. So corrosion allowance shall be included, applicable corrosion allowance consistent with the service and design life of the repair. The coincidence maximum and minimum pressure and temperature of the system unless means are provided to limit the pressure in the mechanical clamp. Designing the clamp for lower range of design and operating temperature than the component is acceptable if justified by heat transfer analysis. The load imposed by the weight of the clamp, including the entrapped leaking of fluid and annular space material, the effect of expansion, including differential expansion or contraction, and the effect of flexibility of pipe or component on insulated lines and components of the clamp may also be insulated to minimize differential expansion. Transient loads, thrust loads in case of full circumferential separation of pipe or component, design of the axial thrust resulting from full circumferential separation may be waived, provided the calculated remaining strength of the degraded component at the end of design life, including expected continuing degradation in service, is determined to be sufficient. Additional restraints may be added to the pipe or component to reduce the loads of the clamp. Where the clamp is intended to restrain longitudinal forces, a locking mechanism or strong back shall be provided to prevent separation. Friction should not be relied to the hold together damaged or separated component to a fluid service that is flammable, toxic, or damaging the human tissue, or if the component operates in the creep range unless the risk analysis document, then risk of failure of the clamp joint is acceptable. Wind, earthquake, and fluid transient, fluid hammer, or liquid slug as applicable. Vents and drains. Vents should be provided for mechanical clamps installed underwater to avoid overpressuring of water trapped in the annulus of the clamp is tightened. The vent or drain includes threaded cap, a flange or a valve that will be open to preclude internal pressure buildup during assembly. The same vent or drain may be used to vent or drain the clamp in future. If leak sealant material is to be injected into the clamp, this vent and drain connections may be used or separate injection may be provided. Consideration should be given to upgassing sealant compounds as they occur. If using sealant injection, the possibility and the consequence of sealant seeping into the damaged component shall be considered. Qualification. Personnel shall be qualified for installing the repair clamp and sealant injection when sealant is applied. The clamp may be installed where the system is out of service or with the necessary safety procedures in service. Leakage stoppage. If a mechanical clamp is installed over a thin or leaking component, consideration should be given to wrapping the component with fiberglass composite or metallic wraps such that the leak can be stopped prior to installing the clamp. This will also prevent introducing sealant into the process. This may also aid future sealing if the perimeter starts leaking. The mechanical clamp may be welded to the component. In the case of welding, examination and testing provisions to leak repair boxes shall be reviewed for applicability of the repair. The assembly shall be visually examined for conformance with the design. Result of examination should be evaluated following the criteria of the applicable construction code or Hooke's construction code. The type of pressure or leak test to be conducted after installation on the basis of risk, likelihood, and consequence of failure of the repair component and the pressurizing the annulus between the clamp and the component. Test method. An in-service leak test if the consequence of an in-service leak out of the clamp is acceptable. Hydrostatic test. When hydrostatically testing a repair on a hot operating condition, caution is required to avoid the discharge of flashing test water. A pneumatic pressure test. A sensitive leak test such as air with bubble solution or helium leak test. Okay, we'll stop here.